Hey guys, welcome back to covalent bonding. We were practicing covalent bonding, and this page is telling us that we are done with 11 compounds and structures related to covalent bonding. And this is a structure for CCl2F2. Okay, let's start another. And this is number 12 right now. And we are now going to practice, for example, let's take N2H4. Okay, it is dinitrogen tetrahydrogen. So it is called hydrazine. It's a specific compound and it is called hydrazine. Okay. And hydrazine, what will be the structure? This is the structure basically. It is basically formed like this. Each of the nitrogen atom is going to share one electron with each other, whereas each of the nitrogen atom is going to share one electron with two of the hydrogen atoms separately. So this is the diagram. The first one is the bonded diagram. The next one is the sharing region diagram, which I'm telling you here. For example, this is it. And these are the two electrons between two nitrogen atoms. These are the electrons of nitrogen and hydrogen atoms. All right. So we can say that overall, there are five sharing regions, and now we can draw the diagram, which are overlapping diagrams. All right, so these are the two nitrogen atoms and these are the two hydrogens on their specific separate sides. Okay, so these I am going to draw. All right, so this is nitrogen here. To make the colors clear, I'm writing with the black for you, so you can see this is dot and cross, 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 dot and cross. For your convenience, I'm writing the key over here. Bacha, this is nitrogen, which is with the cross, whereas hydrogen is with the dot. And we know this thing that nitrogen has 7 electrons in total. When we are going to write its electronic configuration, it is 2 and 5. So 5 electrons are there in the outermost shell. Out of the 5 electrons, 2 electrons will be shared. So I'm going to draw the lone electrons with each of the nitrogen with the green color. All right, so these are the two electrons which are not participant of the bonding, but they are part of the outermost shell with each of the nitrogen atom. But when we are writing for hydrogen, it has only one electron, which will be always part of bonding. Okay, whenever hydrogen is part of bonding, whenever hydrogen is part of a structure, its electron will be always part of the bonding. Why? Because it is having only one electron. All right, so this is the structure of hydrazine formula N2H4. Now I'm taking you to the next board, and that is number 13 structure. All right, number 13. All right. So this is the structure for C2H5OH. All right. So this is called ethyl alcohol. Ethyl alcohol. We will discuss these things, ethyl alcohol, alkane, alkene, in detail, inshallah, when I will teach you the topic of organic chemistry. So this is ethyl alcohol, and the other name of this is Eth-1-ol, and there is a third name as well, and that is called as ethanol. Do we need to keep all these three in our mind? It is better to keep all these three in your mind right now from the earlier stages. Otherwise, one name can be enough as well. Might be examiner will not write down the name for you regarding bonding, but when you are going to appear for your Cambridge, definitely complete syllabus will be in consideration. So definitely a student who has studied organic chemistry should know all these three names. Okay, now we can see that carbon has these many electrons and it is going to convert itself into electronic configuration like this, whereas each of hydrogen atom has 1 electron, so it is like this, and oxygen has 8 electrons, so it will be 8 and 2 and 6. All right, so this is how we are going to draw carbon and oxygen and hydrogen regarding their electronic configuration. Here carbon will be represented with the dot, and you may say carbon will be represented with the black dot, whereas Hydrogen is represented with the red dot, whereas oxygen is represented with the cross. Okay, let's see now. So it is carbon, the two carbon atoms are together, and then they are with five of the hydrogen atoms, um, two hydrogen atoms with one carbon, and the three hydrogen atoms with the other carbon, and then it is oxygen, and then it is hydrogen. All right. So right now we are now going to draw the dots for carbon atoms. So this is this and this is this. Okay. And now we are going to draw the dots for hydrogen atoms. You can see this is this. Okay, now this is this. Okay, now I am drawing the black dot for this carbon as well. And now this is the crosses and the red crosses are there. So this is this and this is okay. We can change it to black so that you may be able to differentiate. Now I'm just encircling, just clarifying the sharing regions. All right, so oxygen has 6 electrons in its outermost shell. Out of the 6 electrons in the outermost shell, only two are the part of the sharing region. So four will be considered as lone electrons. So I'm drawing the lone electrons with the oxygen atom, and then this is this, and this is this the sharing region between carbons and hydrogens, and this is this. Okay, so this is how it is, and I am drawing this. Okay, yes. Okay, so now we can say that this is the diagram. Basically you can see this is how it is happening, and these carbon atoms, the first carbon atom is attached with three hydrogens, whereas the second carbon atom will be attached with the two hydrogen atoms, and next with oxygen atom. So guys, the basic concept which you people should keep in your mind is that whenever there is a covalent bonding, each of the carbon atom is going to make four bonds. Okay, and each of the halogen, which are the elements of group number 7, they will always make one covalent bond, whereas hydrogen is going to make one covalent bond. Okay, one covalent bond in case of halogen and one covalent bond in case of hydrogen, whereas in case of nitrogen it is going to make three covalent bonds, but when we are writing about oxygen it is going to make two covalent bonds. So this is the most common practice which we are doing while making covalent bonding. So you people should keep this practice in your mind, that each of the carbon atom has to make four bonds. So when we are telling about this first carbon atom, you can see this thing I'm pointing out. This is first bond, second bond, third bond, and this is the fourth bond between the two carbon atoms. Let's look at the second carbon, first bond, second bond, and then third bond here with the first carbon atom, whereas the fourth bond is with the next oxygen. But oxygen is making two covalent bonds, one with the carbon atom and one with the hydrogen atom. But we can see all of these hydrogens, whether they are attached with carbon atoms or they are attached with oxygen, they all are making single covalent bonds. So this is the story always. Okay, so please try to keep this thing clearly in your mind. Now I am taking you to another example, and that example is related to, I believe this is the example number 14. After 14 examples, I believe the things will be much more clearer to you. There will be certain structures regarding esters. There are specific compounds which are called esters. I'm writing the spellings over here. This is not esters, bache. This is esters. Okay. So we are going to practice the esters, when practice the structures, practice the covalently bonded structures of esters. But when I will teach you organic chemistry, inshallah, at that time I will teach you how to draw the structure of an ester as well. Right now, I am making the covalently bonded structure of ethanoic acid. It is called vinegar in our regular discussion, but basically in chemistry terminology, it is vinegar, not it is called ethanoic acid. Okay, so CH3COOH, it is ethanoic acid, and it is called as a vinegar. All right, so this is how we are going to write this. Okay, now this is making structure like this, and this is this, and this is this. Okay, So one should keep this structure in the mind. So that C double bond OOH will be written like this. Now the point is this, that six electrons with carbon and 2 and 4, whereas each of the hydrogen has 1 electron, so it is 1, and oxygen has 8 electrons, so it is 2 and 6. Okay. Now the point is this, that I am writing this carbon, and I'm saying that carbon electrons will be represented with the cross, hydrogen electrons will be represented with the dot, and oxygen electrons will be represented with the black dot. Okay, so this is how we are dealing. Okay, now let's see that what we are going to, yes, we are going to take another color. This is the yellow color which we are going to take. So this is this, and this is the first carbon, and this is oxygen, and these are hydrogens. Okay, so I am writing all of them separately. You can see this thing. This is how they are going to be. Okay, now let's make the cross and dot. Hydrogens are with the dot, okay, with the red dot. So this is this. Okay, I know this thing, that each of the hydrogen atom has to share 1 electron. So I have just drawn that. Now we are looking into the black dot for oxygen, and this is this here, and we know it's a double covalent bond. So it is this here, and it is this here, and it is this here. Okay, now come to the crosses, and in case of crosses, you can say that we are going to make the red cross. Okay, so this is this, and this. You can see, whereas both of the carbon atoms are sharing one electron with each other as well. So these are the crosses between carbon and hydrogens and etc. Now we are going to draw the lone electrons of each of oxygen atom. Let's draw them with the black color, this and this, whereas this and this. Okay, so we can say this thing, that in case of this carbon, we have this sharing region with this green color, and there is one carbon and oxygen sharing region which is containing 4 electrons, 2 pair of electrons, whereas this oxygen and carbon are containing 2 electrons. These two are containing 2 electrons, whereas these hydrogens and carbon, the central carbon and these 3 hydrogens, each of them is containing 1 pair of electrons. So whenever there is 1 pair of electron, it is going to originate a single covalent bond. Whenever it is going to have 2 pairs of electrons, it is going to have double covalent bonds. So this is the basic story which you people should keep in your mind. Okay, so this is how we are going to draw the structure of any covalently bonded structure. We have practiced about single, double, even triple covalent bond in case of nitrogen, and I believe that we have practiced for ethine as well, which is containing a triple covalent bond. Okay, so this is how covalent bonding is basically shown. And now if we are writing another example, and that example is not related to covalent bonding, let's discuss about some of the properties of the covalently bonded structures. Okay, so this is number one, properties of covalent compounds. Number one, low melting point and boiling point. Number two, mostly liquids or gases at room temperature. Number three, cannot conduct electricity in any state, very clearly, in any state, due to unavailability of mobile electrons. Why covalently bonded structures can never conduct electricity? Because there is no mobile electrons. So they cannot conduct electricity at all. Okay, so this is how we are going to discuss the properties of the covalently bonded structures. Okay, then it is the next point, and that next point is related to the giant, or you may say large sized. Okay, so giant, covalently, covalently bonded structures. So we are right now going to um, discuss the three giant covalently bonded structures. Rather, I'm not going to discuss them in this lecture, but I'm just telling you the three which are part of your syllabus. Number one is diamond, and number two is graphite, whereas number three is silicon oxide, and it is also called as silicon dioxide. Diamond has chemically formulated as carbon. So whenever if anyone is saying you that diamond is reacting with oxygen, so it means that carbon is reacting with oxygen. Diamond is burning in the presence of oxygen, so carbon is reacting with oxygen. Graphite is burning in the presence of oxygen, so what we will say, carbon is reacting with oxygen. So basically diamond and graphite, both of them are made up of carbon, whereas silicon dioxide, it is made up of SiO2. It is also called as silicon dioxide. It is a basic thing which is part of glass preparation and sand preparation. So silicon dioxide is also called as silicon oxide. Formula is SiO2. And the topic which we are going to discuss in the next lecture will be allotropes. Okay, let's discuss allotropes first, and then I will discuss all of these three one by one. Thank you very much for your help and support. Take care.